In this chapter, in section 2, we are going to try to find out volume of a three-dimensional surface bounded over a closed region. The first problem I'm going to show you is finding the volume of a paraboloid z equal to 4 minus x squared minus 2y squared and the xy plane. In order to find this volume, it is going to be helpful to have an idea how this parabola is going to look like. Though it is not absolutely important for us to actually know the diagram, and I will explain it to you when I'm solving this problem. So if we are interested in how this paraboloid is going to look like, it's going to be an upside down cup of a shape similar to the one that we are trying to get here. And we're trying to find the volume of this paraboloid bounded in between the paraboloid, which is opening down and at the highest point on the z-axis 0, 0, 4, and the xy plane. So it doesn't cross the xy plane and go to the negative direction of the z-axis. I want to know the volume of this three-dimensional figure. So what I do, I first find the trace of this surface on the xy plane. Remember, on the xy plane z is equal to 0. So I'm going to set z equal to 0 and I will get 4 minus x squared minus 2y squared. So I'm going to try to understand on the xy plane this means what. So if you write this expression as x squared plus 2y squared equal to 4, you would understand that this is going to represent an ellipse where the major axis is going to be the x-axis because the major radius is 2 units, and the minor axis is going to be the y-axis with the radius of square root of 2 units. So the shape on the xy plane of the surface of integration, remember this is the surface of integration over which you are forming this three-dimensional figure to know the volume. So if I want to understand this surface of integration in terms of the limits of x and y, and I try to first find the limit of x, then I would know that my x's vary from the left point on the boundary of the ellipse to the right point on the boundary of the ellipse. Because this ellipse is a symmetric figure, one can now say, instead of working out the entire ellipse, why don't I find the surface on the first quadrant on the xy plane? So what I do now, I think about only the first quadrant in the xy plane and see the xy plane in the first quadrant. Limits of x starts at 0 and goes all the way to the boundary of the ellipse. So what I do, I said x starts at 0, and then I set this equation 0 equal to 4 minus x squared minus 2y squared and try to solve it for the value of x to understand how far the limit of x is going to stretch. So I will get x squared equal to 4 minus 2y squared. When I take the square roots on both sides, I get absolute value of x equal to square root of 4 minus 2y squared. Since I'm in the first quadrant, x must be positive, so I get x equal to square root of 4 minus 2y squared. So what I do, I say in the first quadrant, if I am interested in finding the volume of this figure, I'm integrating my x coordinates between 0 and square root of 4 minus 2y squared, and I'm integrating the function which is given in this problem, 4 minus x squared minus 2y squared, with respect to x first. Then I'd like to understand what will be the limiting situation for y. Now if I go back to the first quadrant picture, think about this intermediate point for x, it can stretch from y equal to 0 to the highest point on the ellipse. How much is this highest point? Well, think about this ellipse, set x equal to 0 and see how much is your y. So if you do so, you are going to find out y squared over 2 is equal to 1, which means y squared is equal to 2, which means y is equal to plus or minus square root of 2. Again, you are in the first quadrant, so your y value is going to be positive square root of 2. So the limits of y are 0 to square root of 2. And then I will start integrating this function. So I will get integration 0 to square root of 2. And then I'm integrating with respect to x. So I'm getting 4x minus x to the power 3 over 3 minus 2y squared x. And this is going to be evaluated from the limit 0 to the limit 4 minus 2y squared. So let's see, when I plug in x equal to the upper limit, what we get. And I'm not interested in the lower limit because setting the x value equal to 0, your integration becomes 0. So it's just the upper limit. So you get 4 times square root of 4 minus 2y squared minus square root of 4 minus 2y squared whole to the power 3 over 3 minus 2y squared times square root of 4 minus 2y squared. And I will integrate this with respect to y. But before that, I need to simplify this term a little bit. So when I look at this term, at once it comes to me that I can factor out square root of 4 minus 2y squared from all three of the terms in the integrand. And I will end up having 4 minus 2y squared over 3 minus 2y squared. So this term equals to square root of 0 to square root of 2, square root of 4 minus 2y squared. Let's simplify the inside. You will get 3 times 4, 12, minus 4 plus 2y squared minus 6y squared dy, which is equal to, and I can bring this constant 1/3 outside, so that is equal to 1/3 times 0 to square root of 2 square root of 4 minus 2y squared. Let's simplify the inside. 12 minus 4 is 8, 2 minus 6 is minus 4, so it's minus 4y squared. And then I see that I can factor out a 2 out of these terms. Actually, I can factor out 4, and let's go ahead and do the factorings. So 0 to square root of 2. From these two terms, I can factor out 2. So I will get square root of 2 outside times 2 minus y squared. And from these two terms, I can factor out 4, and I will get 2 minus y squared. As I said, factoring out 4 dy. So bring all the constants outside. You get 4 square root of 2 over 3 integration 0 to square root of 2. Now I'm going to write it as square root of 2 minus y squared whole to the power 3 dy. So this requires an integration by trigonometric substitution. So let's do that. The usual process is we are going to set y equal to 2 sine theta. So I will get y squared equal to, actually I should say y equal to square root of 2 sine theta. Then y squared equal to 2 sine squared theta. So 2 minus y squared is equal to 2 minus 2 sine squared theta. If I factor out the 2, I get 1 minus sine squared theta, which is cosine squared theta. So I get 2 times cosine squared theta. Then I take the square roots on both sides. I get square root of 2 minus y squared is equal to square root of 2 cosine theta. What else I do? Since my substitution was y equal to square root of 2 sine theta, deriving both sides, I will get dy equal to square root of 2 cosine theta d theta. The final thing is changing the limits. So your y limits were 0 and 2. So let's do that. Y was 0 and I think square root of 2. Those were the limits of the integration. And I want to see them in terms of theta. So what I do, I also recall that I have substituted y equal to square root of 2 sine theta. So using that relationship, if I put y equal to 0, I get square root of 2 sine theta equal to 0, which implies sine theta equal to 0. And taking arc sine on both sides, I'm going to get theta is equal to 0. So it will imply theta is equal to 0. What else? Now think about the upper limit. If I put y equal to square root of 2, I get square root of 2 equal to square root of 2 sine theta. Divide both sides by square root of 2, you get sine theta equal to 1. Take arc sine on both sides, theta is equal to pi over 2. So using this new set of limits, 0 and pi over 2, we are going to go back and we will rewrite this integration. So I will get 4 square root of 2 over 3, the constant outside. Limits are 0 to pi over 2 now. Square root of 2 minus y squared is square root of 2 cosine theta whole to the power 3 times dy is square root of 2 cosine theta d theta. Well, then you can simplify that as square root of 2 to the power 3 is 2 square root of 2 times square root of 2 is 4. So that 4 is a constant, will come outside. I will get 0 to pi over 2 cosine to the power 4 theta d theta. So I can integrate that by doing bunch of trigonometric manipulation. So first I'm going to say cosine to the power 4 theta is cosine square theta times cosine square theta. So let's write that down. And then what I do, each cosine square theta, I multiply 2, subtract 1, add 1. Multiply 2, subtract 1, add 1, and put them inside parentheses to make the separate groups. Remember, essentially, I have multiplied 4 on the top, so to make the balance, I have to divide by 4. So this will now become, if I cancel the 4 in the bottom of the integration with the 4 outside, I will end up having 4 square root of 2 over 3, integration 0 to pi over 2. Remember, 2 cosine square theta minus 1 is cosine 2 theta plus 1 times cosine 2 theta plus 1 and d theta. So FOIL it. You will get 4 square root of 2 over 3, integration 0 to pi over 2. This becomes cosine square 2 theta plus 2 cosine 2 theta plus 1 d theta. And I will do pretty similar manipulation one more time in order to make this integrate integrandable, or so that I can take the entire derivative. So 0 to pi over 2. The first term, I'm going to write it as 2 cosine squared 2 theta minus 1 plus 1. That's just the first term. Over 2. That makes your cosine squared 2 theta plus 2 cosine 2 theta as it was plus 1. And all of that is integrated with respect to theta. So I get first 4 square root of 2 over 3, which is the outside, integration 0 to pi over 2. 2 cosine square 2 theta minus 1 is cosine 4 theta. So I say cosine 4 theta over 2 plus 1 half plus 2 cosine 2 theta plus 1. And now I can start integrating with respect to theta. So I keep the 4 square root of 2 over theta outside. Integration of cosine 4 theta is sine 4 theta over 4. So I get sine of 4 theta over 8 because I had a 2 already outside. And then 1/2 is going to give me 1/2 plus 1, so 3/2. So these two you add, they're like terms. So you will get 3/2 theta plus, you have 2 cosine 2 theta. If you integrate, you get 2 sine 2 theta over 2. And you are going to put the limits 0 to pi over 2. So if theta is pi over 2, sine 4 theta is 2 pi. So it is 0. If theta is 0, sine 0 is 0. So the first term doesn't contribute anything in the limits. So I get to say it is 4 square root of 2 over 3 times, first term is 0, plus 3 over 2 times, I do pi over 2 minus 0, plus 2 and 2 cancels, so I have only sine 2 theta. If theta is pi over 2, then 2 theta is pi, sine pi is 0. If I put theta equal to 0, sine 0 is 0, so no contribution. So I get 4 square root of 2 over 3 times 3 pi over 4. When I simplify, I get 3 and 3 cancels, 4 and 4 cancels, square root of 2 pi. Now remember, this is the volume of the figure only in the first quadrant. That's the work we have produced so far. Using the symmetry of this surface now, I will say if the volume in the first quadrant is what we found, and I multiply that by 4, I get the required volume. So I'm going to go ahead and say that. Hence the required volume that we wanted to find out is given by 4 times what we found out. So 8 square root of 2 pi. So we had a surface on the xy plane with respect to that symmetric surface. We have found the volume of the given three-dimensional figure. Then the question tells you if your answer is of the form a square root of b pi, then find a minus b. So I go ahead and write my answer in this format, a square root of b pi. So I say this is a square root of b pi. So a is equal to 8, b is equal to 2. So a minus b is equal to 8 minus 2, which is 6. And that should be the final answer to the question. I'm so sorry. It should be 4 square root of 2. I just made a small mistake. I shouldn't have multiplied the 4. So it should be 4 square root of 2 pi. So a should be 4, not 8. And then when I do a minus b, I should get 4 minus 2. And that should be 2 units as my final answer to the question.